Vulcanization of rubber is carried out by heating a mixture of isoprene and sulfur. Vulcanization of rubber is carried out by heating a mixture of isoprene and sulfur. Vulcanization of rubber is carried out by heating a mixture of isoprene and sulfur. Its explanation: in its natural form, rubber is soft, sticky, and loses its shape when heated. To make it stronger and more durable, it undergoes a process called vulcanization. Isoprene is the main component of natural rubber. Sulfur is added to rubber and then heated. Heat causes sulfur atoms to form cross links between the long rubber chains. After vulcanization, the rubber becomes stronger and more elastic. It can withstand heat and pressure better. It becomes less sticky and more durable. Vulcanized rubbers are mostly used in tires of vehicles, shoe soles, rubber bands, industrial belts. The element having the highest first ionization enthalpy is nitrogen. The element having the highest first ionization enthalpy is nitrogen. The element having the highest first ionization enthalpy is nitrogen, represented by N. Ionization enthalpy is the energy required to take away an electron from an atom in gas form. If ionization enthalpy is high, removing an electron is difficult. Nitrogen N has 7 electrons, 1s2, 2s2, 2p3, with half-filled 2p3 configuration, which is very stable, where half-filled configurations are stable and fully filled configurations are also stable. So, where stable atoms hold their electrons tightly, so more energy is needed to remove one. Oxygen O has an extra electron, 2p4, causing repulsion, making it easier to remove an electron than in nitrogen. In ionization enthalpy, N, nitrogen has the highest ionization enthalpy, and boron has the least or the lowest ionization enthalpy. Neon, represented by Na, and helium have even higher values, but among group 15 elements, nitrogen has the highest because of its stability, small size, and strong nucleus electron attraction. An example of solid soul: gemstones. An example of solid soul is gemstones. An example of solid soul is gemstones. So, a solid soul is a type of colloidal system where solid particles are dispersed in a solid medium. Gemstones fit this category because they contain dispersed impurities or particles that give them their characteristic colors and properties. Where gemstones fit this category because they contain dispersed impurities of particles that give them their characteristic colors and properties. Other examples of solid souls include colored gas and alloys. Colored gas and alloys are the examples of solid souls. Chlorine acts as a bleaching agent only in the presence of moisture. Chlorine acts as the bleaching agent only in the presence of moisture. Chlorine acts as a bleaching agent only in the presence of moisture. Chlorine gas, Cl2, itself cannot bleach directly. It needs moisture, means water, to work as bleaching agent. Chlorine reacts with water to form hypochlorous acid, represented by HOCl, where the following equations goes like this, where Cl2 plus H2O gives rise to HCl plus HOCl. Hypochlorous acid, HOCl, breaks down to release nascent oxygen. O, where the following equation is HOCl, which gives rise to HCl plus O. Nascent oxygen, O, is very reactive where it breaks down color-causing substances, making them colorless. Where nascent oxygen is very reactive, it breaks down color-causing substances, making them colorless. If no water is present, chlorine cannot form HOCl or nascent oxygen, so bleaching does not happen. That's why dry chlorine gas cannot bleach. It needs moisture to start the reaction. Chlorine is an oxidizing bleach that works only in moisture because it produces nascent oxygen, which removes color and stains.
The total number of electrons in one molecule of carbon dioxide is 22. The total number of electrons in one molecule of carbon dioxide is 22. The total number of electrons in one molecule of carbon dioxide is 22.
The compound insoluble in acetic acid is calcium oxalate. The compound insoluble in acetic acid is calcium oxalate. The compound insoluble in acetic acid is calcium oxalate. Calcium oxalate. It is white, insoluble salt made of calcium ions, Ca2+, and oxalate ions, C2O4, 2-. It is commonly found in kidney stones. Acetic acid, CH3COOH, is the main component of vinegar. It is a weak acid, meaning it does not completely break apart into ions in water. Calcium oxalate is insoluble because acetic acid is not strong enough to break the Ca2+ and C2O4 2- bonds in calcium oxalate. Stronger acids like hydrochloric acid, HCl, can dissolve calcium oxalate, but acetic acid cannot. Calcium oxalate does not dissolve in acetic acid because the acid is too weak to break its stronger ionic bonds. Calcium oxalate does not dissolve in acetic acid because the acid is too weak to break its strong ionic bonds.
All-on fibers are made up of polyacrylonitrile. All-on fibers are made up of polyacrylonitrile. All-on fibers are made up of polyacrylonitrile. All-on fibers are made up of polyacrylonitrile, PAN. Explanation for this? All-on is a type of synthetic fiber just like polyester or nylon. It is made from polyacrylonitrile, which is a type of plastic. This fiber is soft, warm and lightweight, making it ideal for sweaters, blankets and winter clothes. It is also strong and doesn't shrink easily, so it lasts a long time. All-on, polyacrylonitrile fiber, which is used for making warm cloths.
The aerosol is a kind of colloid in which solid is dispersed in gas. Aerosol is a kind of colloid in which solid is dispersed in gas. Aerosol is a kind of colloid in which solid is dispersed in gas. A colloid is a mixture where tiny particles are spread out in another substance without settling down. Aerosol is a special type of colloid where solid particles like dust, smoke or pollen are mixed in gas like air. Examples are smoke, tiny solid particles of carbon in air, dust in the air pollution particles. So when you see smoke or dust in the air, you're actually seeing an aerosol. The water gas on reacting with cobalt as a catalyst forms methanol. The water gas on reacting with cobalt as a catalyst forms methanol. The water gas on reacting with cobalt as a catalyst forms methanol. The water gas, on reacting with cobalt as a catalyst, forms methanol. Explanation. Water gas is a mixture of carbon monoxide, CO, and hydrogen, H2. When this mixture reacts with a cobalt-based catalyst under high pressure and temperature, it forms methanol, CH3OH. This process is called the methanol synthesis reaction. Real life use. Methanol is used as fuel, antifreeze, and in making plastics and chemicals. So, water gas plus cobalt catalyst gives rise to methanol. Water gas plus cobalt catalyst gives rise to methanol.
Marsh gas mainly contains methane, CH4. Marsh gas mainly contains CH4, methane. Marsh gas contains methane, CH4. Marsh gas is the gas that comes out of swamps, ponds, and decaying plants. It is mainly made up of methane, which is a colorless and flammable gas. This gas forms when dead plants and animals decay without oxygen. Examples: we found in swamps, paddy fields, and landfills. It's also called biogas when collected for use as fuel. So, marsh gas mostly contains methane.